Very good. So another example. This example says verify that the points 4, 0, 2, 1, and -1 and -5 are actually the vertices of a right triangle. So let us visualize this. What do we have? What do we see? We have our x-axis and we have our y-axis. Since I have -5, I'm going to just expand this a little bit to -5. Okay, I don't like this vertical line. A little bit better. This is my y-axis, this is my x-axis. 4 and 0. 1, 2, 3, 4. Then I have 2 and 1. 2 and 1. The next point, the final point is -1 and -5. 1, 2, 3, 4, and -5. This point down here. So we're going to apply Pythagorean theorem and check to see if we actually have a right triangle or not. But what we need to do, we need to find the distance between these points. Let us find the distance between these points. Then if the distance between points satisfies this equation, then we say that, hey, we definitely have a right triangle here. So let us find the distance between these 2 points. 2, 1, and 4 and 0. This is my x1, y1, x2, y2. Guys, the order is not important at all. You can say, hey, this is my x2, this is my y2, this is my x1, and this is my y1. The formula for the distance says, hey, the distance is equal to the difference between x values, 4 minus 2 to the second plus 0 minus 1 to the second, which is equal to square root of 2 squared plus 1 squared, which is square root of 4 plus 1 or square root of 5. This is the distance between these 2 points, square root of 5. Let us find the distance between 4, 0 and -1 and -5. Well, this is my x1, y1. This is x2, this is y2. So the distance is equal to square root of, so difference between x values, -1 minus 4 to the second plus -5 minus 0 to the second. This is equal to square root of -1 minus 4 gives us -5 to the second plus, here we have -5 to the second power. Well, this becomes square root of 25 plus 25 or square root of 50. This distance is square root of 50. And then finally, let us find the distance between 2, 1 and -1 and -5, or -1, -5 to 2 and 1. So this is my x1, this is my y1, and this guy here is x sub 2 and y sub 2. So b is equal to square root of difference between x values, 2 minus -1 to the second plus 1 minus -5 to the second. Guys, note that in the distance formula, we have difference between x values. Then we have to apply algebra here. This guy is equal to square root of 2 minus comes plus 2 plus 1 to the second plus 1 minus it is plus. So 1 plus 5 to the second. This guy is equal to square root of, here I have 3 to the second plus 6 to the second. So this guy is equal to, just slanting toward that, square root of 3 to the second plus 6 to the second, or square root of 9 plus 36, or square root of, here you have 45. Okay, this says, hey, my distance is square root of 45. So now we need to check to see if these 3 distances they satisfy Pythagorean theorem or not. Is c squared is equal to a squared plus b squared? So c squared, the maximum value is representing the hypotenuse. The maximum value between square root of 50, square root of 45, and square root of 5 is the square root of 50. Square root of 50 to the second is this guy equal to square root of 45 to the second plus square root of 5 to the second. That's why I put a question mark here. We need to check, we need to verify this equality here. So exponent 2 and the radical, they get canceled out. You're left with 50 on one side. Exponent 2 and the radical cancel out. You're left with 45 plus exponent 2 and the radical, they get canceled out. You get 5. 45 plus 5 is obviously 50. 50 and 50, they are equal to each other. What's the meaning of that? It means that, hey, this guy definitely is the right triangle. Perfect.